In this video, we are going to learn how to control 3-color or RGB LED with ESP32 module. I'm going to explain the RGB LED. I'm going to explain the R, G, and B color, and then wiring and code, so you will understand how to control it. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery. And it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. This is the SunFounder's documentation page under for Arduino user. This is 2.3. It talks about RGB LED and what we need. We need an expansion board. We need ESP32, breadboard, jumper wire, wires, resistor, and LED. And here is the schematic for RGB LED. We have 3 LEDs in one, which I'm going to explain it one by one. And we are going to connect them. And to understand RGB LED, we first let's have a look at the LED. LED is light emitting diode. It has 2 pins. One pin is called anode, which is positive. The positive is always long, the anode pin, and then the other pin is called cathode, and it is short. Here is the symbol for the same LED. We have a triangle with a line, and most of the time they put 1 or 2 arrows here to show it is light. The anode is on the back side of this triangle, and the side that has line, it's called cathode. And to turn the LED on, we cannot connect it directly to the power. We have to put a resistor to reduce the amount of voltage that is coming. So we are using it as a voltage divider, right, like this. The resistor can be connected between anode and positive like this, and the cathode is going to the negative. And this is the actual shape. So this is 220 ohm resistor. You will connect it. This pin must be the anode pin, the long pin. So it has been cut and it is connected, so the LED will turn on. We can have the resistor on the other side. So the anode is connected directly to the positive, and the resistor can be on the cathode, and the effect is the same. There is no difference. And here is the RGB LED. RGB LED, however, has 3 LEDs in one. So red, green, blue, RGB, RGB, they are connected like that. If the anodes are all connected together, it's called common anode, and we have 1 pin for the positive, and then we have separate pins for the cathode. So this is called common anode, or we can have it as like this, common cathode, which the common will be connected to the negative, and the anode are separate, so we can control each. RGB LED is sold like this with 4 pins, or as a surface mounted device like this. Sometimes you can see it as a module which all the resistors are already mounted, so you have all the 4 pins, and you will just connect it. So we have common and then red, green, blue. For the common anode, the resistors are connected at the cathode because the anode is common. So we are connecting each resistor for each LED in this package. Or we can, if it is common cathode, then the cathode will be connected to the ground, and the resistors will be connected to the anode of each resistor to divide the voltage and allow 2 volts for the LED. Here's the actual RGB, and here is the picture with a proper explanation from SunFounder. So if we divide it in 2 pin of the right, 2 pin on the left, the 2 pin on the left, the second one from the left is common, which is the longest one, and here we can see this is the longer pin, and that is our common. And then from the left we have red, green, blue, R, G, and B, and here this is our R, and then G, and then B. So you cannot make mistake. If you put it like this, then the long is on the right side, and that's incorrect. So we are going to use it like this. Now I'm on the Bing search engine. Just type RGB color picker with slider, and the first one that comes, click on it. To understand the color of RGB, we have to first know that all colors can be created, or any color can be created from combination of R, G, and B. This area shows the actual color that we have created, and because there is no color, the red is 0, the value is red is 0, green is 0, and blue is 0, so we see black color. Now if I move this, you see some red here, and this is maximum value. Why 255? Because it's 2 to the power 8. So we have 8-bit color resolution, which means from here to here we have 255 steps to add or adjust the color. Of course, there are higher bit rates that can be done. For our purpose, we are using 8 bits. So this is red. Now if I slide it back, the value, you just read it here, pay attention. And this is green, maximum green, light green, and then dark. And then this is blue. So we got these 3 colors. Now the value could be shown also in hex. Pay attention, this is the hex value, but those are RGB. But we are paying attention to this. Now let's have red, and let's put green. So this is red, this is green, and if you combine it, you get yellow color. And if we have red, and if you put blue, then we get pink color. So this is the combination of red and blue. Now I'm bringing that down. This is green now. Green is the maximum. Now if I bring red, you know it was yellow, but blue and green will create the sepia, this color. And if I bring all the colors, it will be white. This is interesting. If you combine the right proportion of R, G, and B, red, green, and blue, you will create a white color. And now if we pay attention, this is 255, 255, 255. Now this color is red is 0, and then we have green and blue, 255, 255. That's why we are getting. And if you want pink, so red is maximum 255, and then 255 is a blue. If we put them at the middle, you will create a darker pink, because we are moving these 2 together, 82, 82, or 83, so they will be the same. Now the fun starts when you play with these values and you create like different color. Orange, you see somewhere here. If we have full red, and blue is 0, green is at the middle. That's you see we are creating orange. If I bring that here and this, we have different kind of blue. So with all this we can create different color that we want, and we are going to practically test it and see it here. For this project we need our breadboard. We need 4 wires. Make sure to get green, blue, red and black, and also we need our RGB LED, which has 4 pins, and then we need 3 resistors. The value is 220 ohm, and then we need our ESP32 board. If you have the extension board, it will make it very easy, so you can use this. Well, I'm going to demonstrate it on this by connecting the wires in here, but you can connect directly using female connector directly to these wires. We're going to connect R pin to the GPIO pin 20. So they are in order R, G and B, R, G and B. So R is 26, G is 20, R is 27, G is to pin 26, and B will be connected to pin 25. So now to do the wiring, we are holding this like that, so the 2 pin are on left side, so the long pin is the left half, and try to spread them a little so it can be inserted easily. This line is separating that side from this side, so we are inserting it somewhere on this area. Here I inserted this as shown here on this wire diagram. Get your resistors and then bend them, and then we are connecting first on this line red, and then leave the common, and then GB. As you can see here, this is on the left red, and then this is for the common. We don't insert anything, and green. So one side is on that side, and then the other side is in here, because this is separating them. And here I have connected it. These lines are the same, so if you connect it there or here, doesn't matter. So red and then empty line, and then green and blue, and the same way on this side. Now let's connect the red to the left side, and here red is connected with the same resistor, and then common will go to this pin, that is common, and then green or G, so G goes to the second resistor, and I left here one empty line, as you can see, and then blue is connected to the last one on this side. Now let's test the wiring before connecting anything. Let's connect the black to common, second pin from here. This pin is 5 volts, and we are going to connect it to 3.3 volts in order to protect the LED. So let's connect the red to this 3.3 volts, and as you can see, the LED was turned on with red. Let me turn off the light so you can see it. Now this is red, and if I remove that and connect the green, this is now green, so the wiring is okay. And let's connect the blue, the last one, and it is now blue. So the wiring is okay now, and then we can proceed. Red is connected to 27, and then G and B. From 27 we go one number below, and we continue. So red to 27, so red to 27, green to 26, the next one, and blue to 25 accordingly. Now let's open Arduino IDE. I'm opening it. Let's open our project by clicking File, Open, go to the left side, Download, ESP32 Starter Kit Main, and then C, and then Code, and here 2.3 RGB LED. Double click, open the folder, click on the file and click Open. I'm increasing the size, and here is our code. First, we have defined here pin 27 as RGB pin of type integer, and then we set constant, so this cannot change during the execution of the code. And then 26 is for green, 25 blue, the same type. And then we are defining pulse width modulation channels: red channel 0, green channel 1, and blue channel 2. They are all integer and then constant, so they cannot be changed. Then we have the frequency for the pulse width modulation channel, as I explained it before. So variable name is called frequency of type integer and constant. And then the resolution, as I've explained it, is 8-bit integer constant. So these are defined. Now inside the setup, which runs from here to here, this code will run only once, and we are using LEDC setup, red channel with a frequency and resolution. So this channel is now prepared for LED, and then we are preparing this green channel 0, 1, 2. This is as if I type here 1 and 0 here and 2 here, but because we defined it in here, we are using the variables. And after that, we have to attach the channel to a pin. This is attach LEDC attach pin, and then attaching that pin to the channel, and then for green pin for the green channel and blue for the blue channel, and this is done. Now in here we are controlling the pins like this. When we say set color, this is setting it as red. As I explained, red is 255, 255. So the red is maximum value is 255, and then green and blue. So the second parameter is for green, third parameter is for blue. And this is setting the color red because red is on and the other two colors are off. When we set this value, the code, the program goes to this function, which is at the bottom here. And when that value arrives here, we define it as integer red, and green is integer green, and blue. So these are our value, and it arrives here, and we say LEDC right, and we mention the channel and the value. So that channel is on, and then we send also the same way green and the same way blue to that blue channel, and we see the color. And then we wait for 1 second, so we see green, and then we see blue for 1 second because red is 0, and then we see green because red and blue is off for 1 second, and after that this is for blue, the same way only blue is 255 for 1 second, and then for yellow, as I mentioned, red and green are on with the maximum, and blue is 0, so we see yellow, and then we see purple 80 and 80 value, red and blue, and green is 0, and then for cyan, red is off and blue and greens are on, so we see these colors. Now my ESP32 is already connected to computer, and make sure the board is selected. If not, click on Tool, Board, and come to ESP32 and select ESP32 Dev Module. After that, we have to select the port. Right click on the Start menu, go to Device Manager. Let's see what port it is. And here under the port, I've shown you before. Now again, mine shows port 8. Yours might be different. Whatever it is, just remember it, because if you connect multiple devices, you will have different numbers. And here, click on Tool, and then COM port. If you see multiple of this, select the one that you saw under the Device Manager. So 8 is selected, and now everything is ready. Let's just upload the code. And here is the demonstration. I'm powering it up with a lithium battery. And as we saw it, red, green, and then blue, and then yellow, cyan. So all the colors that we saw in the code are now being generated. Perfect. And here how you can use the color, you just use this line with the color that you want. But here is an example. For example, you have a variable called V, which is defined or work or available at above this line. And you want to see if the voltage, this is for example a voltage, if it is greater than or equal 12, then you want to set some color. And here this will set it to yellow, but you can change the value whatever way you want. Otherwise it will set to other color, or you can say else. You can say it should be blue, for example, and the blue will go.